description of the Ibsen DISB Software Development Kit. In this presentation we will go through what the DISB SDK from Ibsen exactly is and what it can be used for. To start out, what is Ibsen SDK package actually? Well, it's a software library that has been developed by Ibsen Photonics. It is meant for interfacing with any spectrometer that's using the DISB-USB Bridge to connect to a Windows computer. The package contains a set of specific functions that can be used for Ibsen spectrometers. And the idea here is to make it very easy and convenient to acquire spectral data and adjust different parameters of a spectrometer from Ibsen. It essentially acts as a middle layer between the customer applications and the FTDI drivers that is used to control the USB connected FTDI bridge board. So what exactly is it? Well, currently there are two ways that you can interface with a DISB equipped spectrometer from Ibsen. You can either use the evaluation software that comes with a standard starter package from Ibsen, or you can develop your own application. Both communicate with the spectrometer via FTDI's USB drivers. To start out, we have our evaluation software. This is a LabVIEW developed program which comes with all standard starter packages. It is a package that is generally only intended for evaluation purposes, to evaluate the performance of a spectrometer if it is fit for the end use. It is a software that is essentially made by engineers for engineers, and as thus it does allow you to control all parameters of a spectrometer, but it is kind of basic in its nature. The alternative to this is that you develop your own application, and you would usually develop those based upon the FTDI USB drivers via software examples that are already available on our website if you want that to have a starting point. And these software examples are generally based on the FT4222 DLL files. What is now being introduced is the Ibsen Photonics DISB library, which acts as an intermediate between your application and the USB drivers. This is basically to make it easier to develop your own application. As mentioned, they are developed based on the FT4222 drivers, and they does not require a in-depth understanding to use this software. It basically helps the end user by reducing the amount of code that needs to be written to actually get the application working that they want to have. This helps speed up the development time, and it also improves the code readability overall, as all applications that's used here, all functions that can be used in these applications from the Ibsen library, has names that references what exactly is being done with the spectrometer. It is also possible, at least from the measurements we've performed here, to achieve a higher frame rate than it is with the current implementation that we have through LabVIEW, and by that I'm referring to our evaluation program. It's also possible to use the package to display spectral data directly without the need for any third-party packages. So you can use standard C++ code, and you can ask to have displayed the last amount of spectral data that you acquired. It's also possible to export data directly from the package via function calls in there for later analysis, and you can export to standard format files such as comma-separated files or the like. So what does the package actually include? Well, it includes, to start with, dynamic linked library files, DLLs, for both 32 and 64-bit applications. It also comes with a header file that's compatible with either. Basically, it acts as the table of content for the software, and documentation as well, in the form of a quick guide that entails what can be the package can be used to interface with, and a software development kit manual that describes more in depth what the different functions of the DLL files actually does and what parameters they take in. Included in the package are also software project files with working sample code. These sample codes are written in C++, C#, LabVIEW, Python, and also on top of that we have included a toolbox for interfacing with MATLAB should one wish to do that. In a more visual representation of the same thing, you can see here on top in the blue box we have the Ibsen DISB library folder. From the left we have a documentation subfolder that contains the manual and a quick guide. To the right of that you have an import subfolder which includes the header file, and DLL files for either 64-bit or 32-bit applications. Then, from the middle to the right, you have the different subfolders containing sample code. The sample code, as mentioned, comes in C++, C#, LabVIEW, Python, and MATLAB. Each folder contains a project file. For C++ and C#, you have 6 different sample codes. This sample code includes examples that show you how to read or set new values to the different DISB registers, how to read or write new calibration values to the registers, and how to acquire spectral data and how to display it. For the LabVIEW programs, it's a bit more simple than that. You have sample code that allows you to either read or write different parameters to the DISB board, and there are also samples of how to acquire spectral data, both in a pretty simple bare-bone way, and also how to make the process as fast as possible if you want to achieve the highest frame rate possible. Python have the same coding samples basically as C++, C++, and C#, with the exceptions of the examples of how to display data, as it's anticipated that most people would use packages included in the Python environment anyway. MATLAB is a bit of the same story. It has different functions built in with the and basically all functions of the DISB library is built in there, with the exceptions of functions to display spectral data, as it's again anticipated people would use functions that's included in the MATLAB environment. So what exactly does this package work with? Well, it should work with any programming language that can use a standard DLL file. Looking at a list of the most used programming languages worldwide, we have Python right at the top, followed by Java, JavaScript, C#, the C++ languages, PHP, and so on down the line. And the share here is representing the percentage of code being written in this language. If we start out by cutting down the list a bit, we can remove the JavaScript, PHP, and TypeScript languages from the list, as those are mainly used for web development, so they're not that relevant here. And likewise, we can remove things like Objective-C, Swift, Kotlin, as those are for app development or iOS programming, basically, so not as relevant here either. Then we end up with a somewhat more compact list. And looking at this list that we have here of programming languages, we have developed samples already for the languages marked in green here: Python, C#, C, C++, MATLAB, and LabVIEW is added on to that. LabVIEW is of course a bit different in the sense that it's a flow language, the G language, but it's written in C, C++ anyway, so it is also kind of included under the same banner here. Regarding the last 2 languages here, Java is known to be able to use DLL files, so it's anticipated that you can of course use this package with Java as well if you want to, and it's probably likely that R would work as well, but that needs to be confirmed before we can say for sure. So what functionalities does the package actually have? Well, first of all, it can recognize which version of this board it's connected to. Here at Ibsen we have different tiers of electronics boards depending on the feature set and the detector used. It can retrieve information from all registers that is on the board, and it can also write new information to all these registers here. It's important to know which version of DISB you are connected to, as that will basically control what parameters you need to write to a board to achieve a certain outcome. You need to write something different to the board if you want an exposure time of 10 milliseconds based on the version of board, as an example. It automatically converts register values to meaningful outputs, and this comes back to the same point basically. It differs from different versions of the electronics, what you need to write and where you need to write it necessarily. It can also help you acquire spectral data with an easy parameters input as you go. This means that you can set up a function very basically where you only have a buffer for the spectral data acquired, or you can input more parameters such as a specific integration time, only certain pixels you want to read out, you want to save, do you want to save this data or not on the go, and all these things can be set up, kind of extending the function if needed. Finally, it can display the spectral data. Again, if you have a buffer where you have sent some spectral data to, then these directly in the source code, you can call a function that will display that output. This makes the whole development and debugging a lot more simple than you would usually have it, and a lot more convenient for the end user. And basically what this all boils down to is that it's meant for reducing the amount of code that needs to be written, thus speeding up the development time and hopefully also improving the readability of the code in the process, making it easier to understand the programmer's logic behind the application developed. If we move on to here, we do already have sample code available on our website that is based on the FTDI library. But of course there's quite a lot of things that needs to be set up here, as the FTDI library is a generic library. It's not meant specifically for a spectrometer. It doesn't know it's a spectrometer. So there's quite a few things and parameters that the end user needs to set up before it can actually be used. Comparing that at the bottom here to our new DISB library, it's a much faster process to get going. Both these samples displayed here on the screen, it's being typed out at the moment, simply goes through all the code that's needed to actually interface with the spectrometer, just to find it and initialize it basically here. So what you'll see at the top is all the code is being scrolled through, it's all been written, and at the bottom we're just first linking the library we will be using, then we are setting up a simple handle for the spectrometer to use, and then calling the Ibsen init spectrometer function with the same handle. And that's basically all there is to it for the program to have found the spectrometer, and you are able to use the spectrometer from there on. Moving on, we also achieve higher frame rates using this software package. Generally we see frame rates of around 340 Hz with a 2048 pixel detector. So that's around 100 Hz more than we see with our evaluation software. But of course that depends a bit on the exact implementation, and also depends on what computer is being used, just to ensure that that is not the bottleneck of the whole system. As mentioned, it also has the capability of displaying spectral data directly from the package with no need for third-party packages being installed to export the data or to visualize the data. Here we see an example of a spectrum that's being acquired by a pebble spectrometer from Ibsen, and you can clearly see here that it displays the whole spectral range from 360 nanometers up to 830 nanometers. Finally, the capabilities to display or export spectral data via a package is also here. Here we have used a burst function to acquire 50 spectra and send it all to a CSV file format. At the right at the top corner you see the date and time that the spectrum or the spectra was acquired at. From the third row you see the pixel axis. Fourth row you see the wavelength axis, which is inverse here because we're using the pebble, which has an inversely mounted detector. And from row 5 and down you're seeing all the different spectras being acquired, and there should be 50 spectras in total here. Of course they can't be displayed, but this makes it very easy and convenient to work with, in the sense that you can actually look at the data later at some point and analyze it in another program, or just via Excel, or just for saving data for later storage, whatever might be needed for your application. And that basically concludes all there is to our software. If you have any questions, you are more than welcome to contact Ibsen for more information.